Alright, so now in 8.5 we're just putting everything together. We're taking the probability from section 8.4, putting together with a counting principle using permutations from 8.2 and combinations from 8.3. So we're now going to explore find the probability of an event occurring involving a permutation. So let's consider the following examples in our workbook. So this is on page 148 of our workbook. So in the last election, Miguel, Tasha, Leroy, Juanita, and Mara all voted randomly at different times. How many ways can they have voted? So order here is important. So I've got 5 people, and I'm picking 5. So I'm doing a permutation of 5 people, taking 5 at a time. So I'm going to go and put that into my calculator. So I have my probability key, first option, NPR, 5, enter. So that's 120 ways that can happen. Part 2 says, how many ways can Tasha have voted first and Leroy voted last? Well, if Tasha is voting first, there's only one way that can happen. Likewise, if Leroy is voting last, that's only one way that can happen. So the 3 people in the middle that are left, they can kind of go in any order. So that's going to be a permutation of 3 objects taken 3 at a time. Now we can just enter 3 NPR 3, or if you want to, you can do 1 times 3 NPR 3 times 1. Doesn't matter, it's going to give you the same thing, 6. So there's 6 ways that can happen. So now we want to find the probability that Tasha voted first and Leroy voted last. Well, we have the total number of ways this can happen, and we also have the number of ways that Tasha could have voted first and Leroy voting last. So we're just going to take this 6 ways divided by 120. So that's going to reduce to 1 over 20. Or if you need to write as a decimal, 0.05. So it tells us that's about a 5% chance that it could happen that way. Alright, so now B says find the probability that a female voted first and a female voted last. So our bottom number here is not going to change. That's still going to be 120. But let's think about it in terms of a female voted first and a female voted last. We have to make an assumption here. We're going to make the assumption that Tasha, Juanita, and Mara are female, and that Miguel and Leroy are male. So we have 3 females. So the probability of finding, or the number of ways you can find a female who voted first, you have 3, and you're picking one of them. Now, if you got 3 and you choose one for the first slot, that only leaves 2 females left for the last slot. And we're picking one. Now, those middle 3 people, we can pick that up in any order. So it'd be 3, P3. So we're just going to multiply those together, see what we get. So I'm doing 3 NPR1 times 3 NPR3 times 2 NPR1. Hit enter, and that gives us 36. So we're going to do 36 over 120. That's going to reduce to 3 over 10, or 0.3, which means there's about a 30% chance that a female could have voted first and a female could have voted last. Let's try problem number 2. A combination for a lot consists of a sequence of 4 numbers, each from 0 to 49, and the numbers cannot repeat. How many possible combinations can a lock have? So we've discussed in a previous section that a combination lock should not be called a combination lock. It should be called a permutation lock. We're going from numbers 0 to 49. That gives us 50 numbers, because 0 would be the first number, 1 would be the second number, 2 would be the third number, so on and so forth. So 49 would be the 50 numbers, be the 50th number. So now we're doing 50 P4. So we're going to punch that into our calculator. Going to do 50 NPR 4. And that gives us 5,527,200. So that'd be the number of combinations. Again, I'll put that in quotations because that word's very misleading. Part B then says, how many possible combinations can the lock have if the first and last numbers combinations are multiples of 5? Alright, so multiple of 5, we can have 0, 5, 10, 15, 20, 25, 30, 35, 40, and 45. We don't count 50 because it only goes up to 49. So if we count the numbers here, there are 10 numbers. So the first number is a multiple of 5, so I have 10 numbers to pick from. I'm going to choose one of them. And if I pick that first number to be a multiple of 5 in the first slot, that leaves me 9 numbers left over for the last slot. And then I have the middle 2 numbers, and there's 48 numbers left. And I'm going to be picking 2. Alright, so let's go ahead and put this in our calculator. So we're doing 10 NPR1 times 48 NPR2 times 9 NPR1. Hit enter. So that gives us 203,040. So part C says find the probability that the first and last numbers in the combination lock are multiples of 5. So we're just taking the answer then in part B, which I have in red here, and we're going to divide by the answer in part A. So when we do that, don't think that's going to redo. Well, let's just find out. So I'm going to do a fraction key and grab that first number, enter, arrow down. I'm going to need to enter the second number, 5527200. Hit enter. Oh, it does reduce. So that's 9 over 245. I was wrong then. And let's get the decimal here. So double arrow key. It's about 0.037 if we round it off.